While we wait till 10 past, anyone got any questions so far?
I mostly better want to understand the notation of how basically percent greater than percent and how that functions instead of just writing straight.
Read it as then. So it's basically, it's the equivalent of unit time.
Yeah, okay.
So anytime you read that, just read it as a then. So you're going to do something, then whatever that spits out, you're going to pass to the next thing.
Yeah, okay.
So you now read it as a series of then statements.
Yep.
If you do it that way, it makes sense.
Also.
So we'll cover that again today, but yeah. If you want to have a search, that's called a Magritte R, and it's an hilarious joke about surrealist painting and Unix.
Excellent.
It's classic.
It also took me forever to install all the packages necessary to run this in as logic.
Yes, it would do. Yeah, absolutely. So hopefully you all have a laptop, or you can see a laptop, because really the best way of doing this is to work along as we go. So while we're waiting for people to arrive, if you haven't done it, hopefully by this point you have R and R Studio. Hi Caitlin, come in, grab a seat. Hi Dennis, come in, grab a seat. Probably grab a seat next to someone who has a laptop so you can, perfect. So if you haven't already got it, you'll need R and R Studio. I highly recommend, unless you're really good at what you're doing and do Emacs and stuff like that, stick to R Studio. I've recently discovered, i.e. last weekend, a thing called Pacman. Pacman is a really nice package. It's short for Package Manager. And what it does is if you run the Pacman command, so let's remember, if I go pacman : it says this function is within this package. That's all the : means. If I go pload and I give it a load of packages, what it will do is, if it's not in your system, it will try and install it. And as long as you're connected to the internet, it will still fine. And then it loads it. It also has an advantage for me, it loads it quietly, but you don't really care about that. So what I'll do is at the start of each workshop, I will have a slide like this that will just tell you. So if you run this command, when you walk in here, you should have all the packages you need to do this. So we're going to talk about a thing called functionals today. And all a function is a function that takes a function as an input and returns a vector as an output. The reason I give you that name, I very rarely call them functionals, but often if you're trying to search this, the best thing to do is search for functionals. And there's a whole series of functions that do this. There's things like the apply function, and that has various formats. And then nowadays in the per package, there's all the map functions. And what I'm going to try and do today is show you why you would even care about doing this. So first of all, a common thing you might have is you might have a matrix or a data frame, and you would like to do some calculation on every single row of that data frame. Because remember, the standard data frame form, usually within R, is each row is a subject, each column is a variable you measure on that subject. So often you want to calculate something for each subject. So, open up a script, type that in, run it, see what it does.
Hello. Is this the intro to our workshop?
Not quite intro. Actually, it is intro. It's intro as you know, they get books that are called Intro to Probability, and you start to read it, and then you wake up in the hospital. It's that sort. Luckily for me, I have. Hello. Hello, come in, grab a seat.
Good, how are you?
So, what does this code do? First of all, why do we go set.c?
So we don't get the same
Yeah.
results?
Remember, we're going to be doing simulations. It's really nice to have reproducible results. So you set your seed. I often just use the year we're in, but it doesn't have to be. Right, I've set up n equals 100. You might say, well, why didn't you just shove it in here? I didn't want what we call a magic number. I don't want numbers in there. I didn't really explain, although then I completely break my own rule by having n equals 10 here, but you know, such is life. So what I'm doing here, I'm creating a matrix. So I need the elements of the matrix. Basically, I'm doing random normal of 10 times n, so I've got 1,000 observations, and I'm going to set the number of columns equal to 10. And then I've converted that to a tibble because it's just a nicer form. So I said as tibble. If you have the latest version of tidyverse, it complains if you don't put that command there. That's all. That's why that command's there, is it kept complaining at me. Old versions of tidyverse won't have that problem. But all we've done here is we have created a data frame that has 100 rows and 10 columns, and it's just filled with random normal observations. This is now my data set. So imagine I wanted to get the row means. Maybe this is repeated measures. Each of these is a individual, we've measured blood pressure or something like that, and I want to get the row mean. Well, here's how you could actually do it as a for loop. First of all, I'm going to set up a vector to grab my data. I then go, well, let's count down each row. And what I do is I say the ith element in that vector, I will bet by getting the mean of the ith row. And that's the standard way of doing it. There is nothing wrong with that, as long as obviously you don't want to do any analysis in your lifetime. Absolutely fine. You know? Seriously, if you really, this A-line was so nice today, I realised that she just flattered me because she's using for loops, and hence wants to spend at least an extra 2 years in her PhD with me. I was flattered. I think that's very sweet. But I don't want you to do that. I want you to start thinking about apply. And that looks also, I'm going to try and argue that functionals have a clarity to them. Because there's a lot of machinery around there when all you really want to say is, for each row, do this calculation. So what I'd like to do is type in the first command. So put in the for loop so we've got it. And then if you've all got the for loop, so, and run that and make sure it does what you think it should do. Josh was raising a good point earlier. He goes, how do you know when your code's working? Honestly, always stop and check. I have sometimes just gone the simple thing and got that first row, quickly added them all up on a piece of paper, divided by 10, had an idea of the answer, and then I looked at the first element and see if it's about right. That is my code not working, because all code will work eventually, but is it correct is a subtlety that you have to learn over time. So here is the apply function. So, come in. Hello. How are you doing? Good. Grab a seat. We'll be having a break in a second for catch-up, so don't worry. So this is your first functional. And it's a thing called apply. So apply is going to take some data and a function, and it's going to apply that function to that data. Okay? So if you look at this, it says apply. The first thing I do is I give it the data. And then the next thing you do is you give it either a 1 or a 2. The 1 says apply to every row. The 2 says apply to every column. And then you give it its, what's wrong with that? If we made it easy, everyone would do it. And then the final thing is you give it a function. And in this case, I've given it the built-in function mean. Okay? This is doing exactly what we did before. It's going in and it's quickly producing you a vector. It's basically doing almost the equivalent of that for loop. But all that machinery you had to do before, create the vector, count, make sure you get your eyes right, do the application, know how to get the row, is all done in one go. So I would argue that this is clearer. But it has an extra advantage. If you think about it, if I wanted to calculate these means, I could just sit here and do it by myself with a piece of paper one by one. But instead, if I went, Luke, you do the first row, you do the second row, you do the third row, you do the fourth row, and we all take roughly the same time to do one row, we get the results much quicker. Because by the time you've got the fourth row, you've already got the third, second, and first. What we call parallel coding. You can do that. And what apply does is, it won't just go the for loop, it will actually go, I have how many cores, which is equivalent to how many people. Right, you go and do these rows, you go and do these rows, you go and do these rows. So if you have 4 cores, it should be roughly 4 times faster. It's just doing it in a clever way. Because it knows that you're just doing the same thing, in this case, the number of row times. So to answer the question now is, does it work? Well, we believe the for loop. I've now told you applied does this. Let's check it works. And the way I checked it works was with identical. Identical will take 2 objects and compare them and go and say, are they identical? And in this case, we got a true. So what I've done here, because there's not much point believing in me just because I said it so, is I'm now using micro benchmark to do some profiling. What micro benchmark does here is I said method 1 is my for loop. Method 2 is my apply. And it will go and it will run this 100 times and time it. It will run this 100 times, time it, and then it will give me some statistics on how long it took to do these things. And if you run that, depending on your machine, I got this. Method 1, which is the for loop. If we look at it, it says microseconds. Its mean is 6,000 microseconds. My apply, which one, once you understand how to do it, was a lot less typing for me, was a magnitude faster. Okay? So, why do you learn apply? 1, I think it makes your code easy to understand as you get better. The first time it's hard because you know for loops. And it's faster. Okay? So, let's test if you can do that. What I want you to do, first of all, write a function that will take a single row, and for that row, return the number of positive values, and then apply it to every row. Have a go. Bump. You just did it, that's fine. And you don't have to, you can actually do it as an anonymous function within the apply. But I would suggest to these that they do it as a separate function.
I wasn't even thinking about writing function. Old habits.
Yeah, but we've got it to be the. So if you look at
See, I actually wrote a proper function.
Showing us the answers already, then?
No, I will show the answers. I will put the solutions online. Absolutely.
This guy's the GM greater than 0.
What?
That's the GM greater than 0. Yeah, that's right. Old habits die hard.
I do now when I'm writing code. I mean, the anonymous function is great hack code, but I would actually write this because the number of times
Oh yeah.
you've got this embedded in something and you lose track. Well, if you have a function that says this returns the positive numbers for a single row, and then they apply, it just gets that clarity.
Well, that makes sense.
And I would argue that apply makes your code faster, but the anonymous function doesn't. You got it to work, Josh? No wrong with that. Gives you lots of something to look at in the distance. In front of you.
Yeah, so
No, I'm curious about how we've got the same computer.
Excellent.
Oh, right.
How fast? Thing we had to do earlier, but we did the two different methods.
The micro benchmark?
Yeah.
your computer's super
Curious if
slow.
we have like the
Huh?
same
Your
computer.
computer's super slow. Like, when you must have been doing something else at the time. Because I was getting like 12 milliseconds.
Wow.
And that was for the
That's
forward.
microseconds.
That's why I'm. Oh, okay.
Yeah.
That's why I missed it. Well,
No, I had the same thing. I was like, what? No.
Yeah.
I'm just dyslexic.
I mean, this should be quite good. I don't even know how many cores this has.
I'm surprised.
And I could actually be more precise with my detect.
Yeah. Even though it's only twice as fast as my.
I've got 12 cores in this.
Yeah, yeah.
So,
It's funny because this I bought to go to a training course years ago, and I just installed it because I wanted
Yeah.
to use it still.
but I'm not, you know, when I said that it uses your cores, it doesn't really. I think you can actually be clever and actually use a thing called mapply. And mapply is much more precise, and you can absolutely say,
Also,
here's the course I want you to do.
and also with cores, the speed increase is only log, not exponential. Like, this is why Moore's law no longer exists. Stuff. All that boring stuff.
I'll give you another 2 minutes. I will obviously put solutions to the DIYs online, so if you want to sort of keep going, having a go, obviously like you've already got it, and just check.
I got my main to be 38. 6,000.
And if you think that I was bored using Apply, I have to tell you, I once had a summer job working with Gary Glonick, and he gave me some data, and I spent a whole day trying to do some calculations using for loops. And at the end of the day, he said, "Where's my results?" And I went, "I'm still getting the for loops to work." And he laughed, wrote one command, and just went, "That's how you do it," and walked out. And that was a valuable lesson in humility that I've never really forgotten from. So when I say don't use for loops, it's probably because I'm psychologically scarred by Gary.
I used to
Oh, yeah.
Okay, so let's go to the next step. So apply will solve 90% of your problems. It's actually really, really lovely. It's amazing how many times you have a data frame and you just want to apply something to every row. There's other versions, there's vapply, lapply, etc. And lapply is an important one. Lapply stands for list apply. We'll apply a function to a list. But I've stopped using lapply and started using per instead, just because I think it's a bit more user friendly. So, per, P-U-R-R-R, is part of tidyverse, and it just gives some very nice wraparound functions to what we call map functions. So let's think about what we mean by a map function. So we're going to start by reminding ourselves what a list is. So first of all, a list is a collection of objects. And these objects can be almost anything. To be honest, if you've done any R coding, everything you've pretty well manipulated or looked at is a list. So, for example, here's my first list. You create lists by using the list command, and here I've said the first object in my list is just 10 random normals. Then I've got a vector of 1 to 3s, and then I've got a vector there. So I've actually got 3 objects that contain, in this case, numbers. They don't have to be the same time. I could have an object that some of them are booleans, some of them are strings, some of them, whatever I want. It's just a collection of objects. And if I say my list, here it does. And the way it indicates the first one is it uses the double square brackets. So the first object in the list you get by going, square bracket 1, etc. So here's the first object, the second object, the third object. And let's say I had a list of objects like that and I want to do something as simple as, for each object, calculate the mean. Now you could go and use your for loop. The only catch now would be when you do your for loop, you'd have to go and say, get the mean of list, square bracket up. And that's absolutely fine. But again, you've got a lot of housekeeping to keep in track there. Well, map does it for you. Because let's read this. I'm going to take that list. Right. Ross said, what's that? This is Magritte. This you read as then. Then, map mean. What does this mean? It says, basically, map says, go and get the first object, apply this function. Go and get the next object, apply this function. When we talk about mapping something, what we really should say is, apply the function to the object. So this is saying, take the list, for every object, calculate the mean. And that's what it does. It goes bang, bang, bang. You give it a list, it returns a list. The first object of that list is now the mean of the first object. The second object is the mean of the second object, and the third is the mean of the third object. Okay? And you could have got that with lapply. Lapply did this already. That was fine. But you can be a bit clever as well. Because it has extra forms. If I now do the exactly same command, but I go map underscore double, what you're saying here is map this function to every object, but instead of returning it as a list, because remember map takes a list, returns a list, return a vector of doubles. There we are. And as I said, it's that horrible like, I don't get your code, but once you start getting you think about that thing of, I have a load of objects. I just want to do the same thing to every object, so I'm just going to map to every object. And then the next thing, once you get that working, you go, would it be better to return it as a list or something maybe nicer? And it's called a map. Okay. So what's a data frame? Told you everything's a list. A data frame is a list where each object is the column of that data frame, and the only extra rule you need is all the objects are the same length. It's built into the system, but you don't realize it. But this now means we've got something amazing. Because now, before I said map goes, go to every object, do this. If I give it a data frame, what I'm saying is go to every column and do this. So, we'll go and get some data. We're going to get the miles per gallon data set. So I take my data frame, then I'm just going to select all the columns from displacement up to cylinder. And then I'm going to map, I want the mean. So that says, for every column, get the mean. So try that command, see if it works on your system. Yes, absolutely. I find it even better than apply sometimes. Apply is fast because it's like fundamental in the R structure. I find this is pretty darn fast. Yeah, I must admit, it's amazing how fast and how nice, isn't it? We had a good one yesterday where it worked really nicely, luckily for me. I know that, like in MATLAB, vectorization for your code doesn't always work nowadays because MATLAB's got clever enough, it looks at your for loop and smartens it up. Remember Trent getting, well, not angry because he was already angry, more angry, were you? Where he was trying to show me that, you know, vectorization works so well, but he actually had to say to MATLAB, stop being so clever, because every time he ran it, they were going at the same speed. Someone told me recently as well that in R, it looks at your code, and sometimes you'll find that you run a command and the next time you run it, it's faster. Because it seems in the background of R, they are doing a similar thing nowadays. They're starting to look at it and going, can we speed it up somehow? Which is quite nice. Did everyone get the same results? So this has now gone, and it's actually been cleverer. Instead of returning the bracket, bracket, 1, bracket, bracket, it was nice enough to look at the column name and go, why don't I just return the column name as well? So we know the mean for displacement is this, the mean for year is this, and the mean for cylinder is this. But what you could do instead is that, you know, I said the special functions of map? If I go, instead of just map, and I get a list, if I go map underscore df, it returns a data frame. So now I've taken this one command, I've applied it, and it spit out the mean. This is a really useful thing. As you start using bigger and bigger data, the classic thing I will do is I will do genetics data, and they will have 200 genes. And what I want is things like, you know, do a quick calculation on each column. And I just write my function, does it on one column, and then I just go data frame, map, do all of them. It's fast and it's really nice. And for univariate descriptive statistics in data sets where I have a lot of predictors, this is very, very useful. And we can be clever, because I chose the columns to be numeric, so it would work. Because otherwise I would go data frame map mean, and it would get to the first thing that's a factor, and it would fall over. It would stop and it would go, I can't get the mean of a string. It won't say that because it's R. It will say something in archaic Latin, but you have translated that as I can't do that, it's a string. So instead, the select, I can do clever selecting. I basically said, take my data frame, then select all the columns, if that column is numeric, then I want a mean. One line, got the mean. I can do one line, get the standard deviation, one line, get my 5 number summary statistics of everything that's numeric in that data set. Please try not to tell anyone outside this room, we charge $2.50 an hour to do this. If they realise it takes a minute, I'm only going to get coffee. If I say I'll do all them, oh, 200, that's a good hour, that is, I get more coffee. Just keep it amongst ourselves, please. Okay, have a go. I would like you, for the MPG, to return a data frame with a row for each numeric variable, so you're now going to get a row, and I'd like a column for mean and median. So always remember there's more than one way to do this. My way isn't the right way, it's just a way. So if you look at my code at the end and go, oh, I wouldn't have done it that way, maybe your way was better. If it's a lot better, can you let me know so I can steal it? Just so you know, the trick I would do with this is I would write a single function that would take a single column and return a data frame. Okay, it's only going to be a data frame with one row that would have the mean and the median. You got it sorted, Anthony? Keep going. I'm sure you will. As I said, the key is to break it down to a single. First of all, I'd write that function. Takes a column, returns a data frame with the mean and the median. Now I've got that function, I can put it in my map. So, if you think about where we've got to now, we're using this map, and we can now apply something to every column, which is really useful. You can basically get your univariate sum statistics using this. But the next thing you'd like to do if you're going to do any sort of model is see the relationships, the bivariate relationships. Yes?
How do you get into the columns rather than the rows?
So what I did, and this is not the only solution, is I did that. I've got a function called getMM, and it takes x, and it creates the mean, it creates the median, and notice it's returned it as a tibble in this case. And now, the second trick, the second gotcha, which is really nice, is I went MPG, selective is numeric, then I did a map, because I want to apply this function. You think about it, every time I apply this function, it's just going to return a little single row data frame. The first column will be the mean, the second one will be the median. And the thing about the map underscore df is it really wants a data frame. It will try and mess around if you just give it numbers and do that one where we do it wide. But if you actually return a data frame, it takes the first one, then it takes the next one, and it puts underneath. And the next one, and it puts underneath, and the next one, it puts underneath. The problem I don't have at the moment is I don't know what the name of the column was. So I use this very simple trick. I add an extra column called .id equals column. And remember before when we did the list, it got the name? It will now put an extra column with the name of each variable. Very nice, very sweet. Anyway, so the next one is bivariate analysis. So I'm going to give you this as a template. We'll walk through it because it's a very useful template. Let's think about what we're going to do. First of all, I take my miles per gallon data set. And the first thing I do is I say select every column except for CTY and except for highway. So that's going to return exactly the same data frame, but then two things are gone. Then what am I doing here? I'm going to do a map. So it's saying for each column, I want you to do something. And I've used our first now. We're going to actually write our function on the fly. We're going to do a little anonymous function. So you put the tilde to let it know that you're going to be doing an anonymous function on the fly. And I'm going to do a linear model where I'm going to regress CTY on, well, what's this doing? The .x is standing in for whatever the object is that you've passed into me, which in our case will be each individual column. So we get to the first column and go, right, I better do a regression of CTY on that. Then I'll get to the next column and do CTY on that. And so for every column, it's going to do a linear model. We better just let it know where the data is. So this is going to spit out altogether a list with a linear model. So now my object's a linear model for each column. Hence the reason why I took these two out, because these are my response variables. I didn't want to regress it on itself. It will have difficulty. What's the next thing I do? I take each of these lists, so now I've got a list of linear models, and I go, well, get me some summary statistics. So it goes to the first one, and it looks at it, and it gives me the glance. So Broom glance will give me the summary statistics of that model. It will give me the R squared, the BIC, the AIC, everything. And it returns it as a data frame. I don't have to worry. It's going to return it as a data frame. So I can stack them together by going map underscore df. .id equals predictor. So what have I got now? I've got a beautiful little data frame. Every row is a linear model. It has a column that tells me the name of that linear model, as in which predictor I used, and it will have R squared, AIC, BIC, p-value, everything. Fine. Now it'd be nice to know which of these predictors are significant. So the next thing I do is I create myself a new column by using p-adjust. You know, if I've got 20 predictors and they're all useless, by the nature of statistics at a 5% level, I expect at least one of them to be significant. It's the whole idea, you know. Significance level of 0.95 says I make a mistake 1 in 20. If I do 20 things, I'm going to be, you know, on average, make a mistake 1 of them. So I adjust. The way I adjust is I convert to false discovery rates. So I can take my p-value, I'm going to get an adjusted p-value, method equals false discovery rates. I then go, right, let's find all the ones that are significant. Let's arrange them in ascending value. And then let's just have a look at the predictor, the average. And here we are. Cylinder is the most significant. There's its p-value. Beautiful, beautiful way. I mean, this template has got to my point that if you don't have it, have some sort of boiler template code storage where you keep them all. And every time I get a new data set, I grab it, I paste it in, I just change the data frame and the things I have to change, I run it, and then instantly I can say, right, you have 200 genes, I can tell you here's the list of significant ones. I usually then save that and I put it in a nice little plot for them. And this is not idle gossip, this one I used the weekend before last to do jam stuff on opioid dependency and genotype. And there she had 200 genes, and I seriously ran it and just went, these are the genes that are significant predictors of dose rate and opioid dependency. So it's a really nice one. It's a huge, I always say it's a one-liner. It's not really. It's just put together, but it's that sense of take the data frame, then we do something. Does it make sense? Yeah, then we do something. The best thing to do with this is, I'll show you the best thing to do with this. If I was absolutely using this, and there's my command, what I do is if I can't remember what this does, is I go to the first bit and go, what does that do? Oh, it gives me that. Then I come down here, I break it, I go, what does that do? Oh, that one's gone. And then I come down here and I go, let's break it. What does this do? Oh, here we are. It's given me a linear model. So by breaking it apart, you can actually look at every individual step and say, what's it doing? That one did nothing, which is a bit weird. Where is it? Oh, there it is. So there's that summary statistic. Because this is just a series of steps joined by thens, you can always break at any point and see what it's doing at that step. And when you get someone else's code, it's really worthwhile doing that. Same as, it's the coding equivalent of a proof. Go to the first line. How did they get to the second line? Why did they do? Annotate that proof. Think about what they did and how they did it. Keep doing it again and again. Okay. So now we've got these map functions. We've got this idea of we can apply stuff for each column. We can even get lots of linear regressions. Now we're going to look at a thing called a nested data frame, which is a way of just making things a bit nicer when you're looking at big models. So what we're going to do is we're going to load the Gapminder dataset. The Gapminder dataset is based on Hans Rosling's work. It basically gives a lot of statistics of countries around the world. What we're going to do is we really want to, is for every country in the world, it has data that has life expectancy against year. But in some cases, I think 50 to 60 years. And what we like to do is go to this data set, grab a country, fit a regression. Put that country back, grab the next country, do a regression. So now we've got a complicated structure. We'd like to look at each country one by one. As soon as you've got the idea of taking an object one at a time and applying something, you should be thinking about maps. And we're going to return that whole thing. So we have a coefficient for each model as a data frame. So first of all, we can load the Gapminder. And here you can see what we do is have a whole load of observations. It's going to be for a year and a country. So the first one is Afghanistan in 1952, had a life expectancy of 28.8. This was its population, and this was the GDP per capita.
And 28.8 years.
Yes.
Whoa.
It's a good data set, it's a true data set. Go and have a play with it if you're actually interested. If you're really interested, start watching Hans Rosling's his videos on YouTube. They're brilliant. They are absolutely brilliant. The sword swallowing one is just freaky. So that's our data set. So what we want to do first of all is we'd really like to sort of go and grab all the data for Afghanistan, all the data for Australia, all the data, etc. But instead I'm going to do this. I'm going to take my Gapminder, then I'm going to group it by country, and then I'm going to nest it. When all that's done is it's now got a data frame. Because it's grouped by country, every row is a country. For the first time ever, if you've never seen it before, now the second column is basically this, is the 12 times 5 data frame that represents all the data for Afghanistan. It's basically taken that data frame and shrunk it down and put it as an entry within another data frame, hence it's nested. So it's just split it up. So now every row is a country, and that little thing is a little object that's packaged up, almost like instead of having a number there, you've got this whole data frame squashed into that one cell. Okay? So how does that help us? Well, it gives it a nice ordered structure. You can still get your data. If I went to get my nested data and I said give me the first one, notice because it's actually a list, it's a list of objects and each object is a data frame, it just returns that data frame. And remember that, it just returns that data frame, it's just a list. If you go down that column now is a list of data frames. And once you've got a list of data frames, you can just use map. So what I'm going to do now is I'm going to write myself a little model. What does it do? It will take a data frame, it will do a linear model of life expected on year, where the data is that data frame, and it will return the model. So, I'm going to take my nested, then what does mutate? Mutate produces a new column. And all it does is produce a new column. And when I produce a new column, I need to say what the name of that column is, but I'm going to call it model. And then how you get that new thing. So this thing is going to take the data, which is a list of data frames, and map my function. So it takes the first data frame, it returns a linear model. It takes the next one, it returns a linear model. But because it's a nested data frame, it just goes along, it gets a column, and it will put each of them linear models in it. So, just go back a second so you can actually see what that looks like. So, if we just... So when I do this, what it actually looks like, if I just go get nested, is it did exactly what I said. It went to the first object, it ran my function, so it fit a linear model, and then it's got a new column, like I said mutate would do. And the first entry of that is now a really complicated little thing. It's actually an S3 object that's a linear model. So now I've got a whole list of linear models. Again, I can do map again. So what I do now is I go, you know what I'd really like? I would like to take my Gapminder nested, I want to create a new column. The new column is going to be called coefficients. It's going to take a model, and for each model, it's going to apply the function tidy. So it's going to return me a data frame. So if we now go back to what we're doing here, if I run this and now look at it, what do we have? We have an extra column, which is a tibble. It's a little data frame, and inside each of them cells is a little data frame of the coefficients. If I want to grab them, I can go, there's my data frame. Inside there's coefficients. If I grab one, there are the coefficients and estimates of everything about the very first one, which was Afghanistan. The problem is at the moment is it's a little bit stuck, isn't it? I've got this beautiful structure. Every row is a country. First column tells me the country, the second one contains my data, the third contains my linear model, the fourth contains the coefficients of that linear model. But I want to get it out of there. So what you do, if you think about it, is I took it and I sort of shook it down into a nested structure. Eventually you can go, right, I'm ready, you can unnest it. And basically it will take that whole thing and it will expand it out and return one big data frame. So that's what we do. I take it, I now unnest, I tell it which column to unnest on, and now I've got a big data frame where I have 2 rows for each country, one which gives me my intercept, one which gives me my slope. And now, I'd like you to go through them commands one by one, type them in, make sure they work, make sure you understand them, and then once you've got that final data frame, answer the simple question. Do any countries in the Gapminder data set have a decrease in life expectancy over time? Go for it.
My group is broken.
So you've gone, where should you go? You went to Gapminder, group by, and nest. No, it's nesting, isn't it? We don't know.
Let's see.
So let's go. Command Shift M. If you ever need to make your tools, keyboard shortcuts help. It has them all. And you can adapt them if you don't want to use that one. You can also see all shortcuts. Group by. Good. Not sure why yours isn't working. Yeah. You have 2 nests. So I forced it to use the film one in cardio, which is part of it. Counted to do the first thing. Yeah. So that's why. So I've just been precise about which nest to use.
Yeah.
Sure.
So which countries over this data frame had a negative? Fun?
Arranging its call.
You could have just filtered on estimate less than 0. So unfortunately, I think we can explain Rwanda because of the Rwanda genocide in the late 90s. It's probably a major problem. Don't know about Zimbabwe and Zambia. I don't use nested data frames as much as I should do. Everything up until this point is really, really good. I find I just end up doing maps. The nested gives you a nice compact data frame, but I don't find it's as intuitively nice. But I'm not saying don't use it, it's out there, it's really, really good. If the stuff I've done isn't as clear as you'd like, which is basically, you know, my teaching philosophy, I've given you lots of resources to follow up. If you don't know by now, The Art of Data Science is a great book to keep going back to. The Many Models gives you exactly this data set a walkthrough. So I'd highly recommend if you want to use this more, if you find it very useful. You're mainly going to find it useful because I want you to do something similar to this in question 4 assignment 1. So, but it is actually quite good. The non-standard evaluation I've left there as an extra for you. Mainly templates, but the whole idea is how do you write functions that can have dplyr inside the function, that you could pass arbitrary columns in, etc. So that's there for you to go through if you want to have a go. I find it quite nice. You do need to learn things like bang bang and end quote. So bang bang and end quote is in there, and I've got links for it if you want for completeness. So call it quits there. If you've got any questions, come and see me. If not, I will see you on Monday where we'll recap ROC and then we'll start LDA, QDA, etc. So more classification. Thank you very much. In a fortnight's time, we will be doing RCPP. That's one I definitely think you should look at the prerequisites and make sure you have a compiler installed. There's instructions in the slides. And also what I've done is I've got a piece of code you can copy and paste. And if that runs, you've done what you need to. If it doesn't, it doesn't. Simple as that. Thank you very much.